This is 2010 section A, higher level question. Now this is a really nice normal kind of conic section question. In this case it's a parabola. Alright, draw the parabola, draw a tangent. Okay, so we've seen this kind of thing before in a few different bits and pieces. And the only catch with this one is you need to know a little bit about a parabola. You need to know for a parabola that the eccentricity is 1. Okay, once you have this, it's all plain sailing. Alright, that means we just draw a curve with our 45 degree. Okay, so there we go. That's our eccentricity line. Now, how do we go and get our bits and pieces? Well, let's go find the vertex. That's always a nice place to start. So we go up here at 45 and down. And there's our vertex. Okay, you can see that because this is the same distance here and here, because these are all 45s, it's the same distance from the focus to the point, from the point to the directrix, because that's what eccentricity is, of course, from the focus to the point, over the point to the directrix. So now that's our vertex. Great. Now, where to go next? Well, we're going to draw a nice big line here, and it's an important line, so we'll give it the honour of being a nice orange line. Okay, and they do seem to want us to draw the bottom of the parabola here as well. They're never very clear in these questions. Draw a portion of the curve, but look, they've given us the space, so let's take the hint. It's actually quite easy to draw the other side, as you'll see. Now, this line coming up here, of course, our fabulously named latest rectum. All right, we know that there is a point here tangent on this line. Okay, so it's tangent from the eccentricity line. So that's another point. I wouldn't mind one in the middle here. It's going to be a bit annoying to draw otherwise, so we'll go get this guy done first. Okay, up to the line. And across, and there we go. And really, all I'm actually doing is taking that distance there, okay, and just copying it from the focus, because anywhere along this line is the same distance from the directrix. So my point's going to be somewhere along the line. Okay, and it's going to be that distance from the focus. And the eccentricity line divides it up. Now it's much easier to do if you just come back here and you can bring your compass over a little arc. So it's a small thing, but that's why you have that slightly funky construction. Grand. And look, maybe you decide it's actually kind of annoying to see what's happening down here, so we'll just do another point. You can see it only takes a couple seconds. Oh, sorry. A couple of seconds is easier if you do project it back. There we go. So if you find you're struggling with the freehand, just throw a few extra points in. There we go. Now, it becomes a little bit easier to see where our curve is going. We need a few more out this side, so I'll get about another 3 out this side. I wouldn't even bother measuring these guys. I would just draw lines that are roughly equidistant. It doesn't really matter. Because remember, you're just getting a selection of points that helps show you where the curve is. And these work pretty well in a batch. There we go. Bring this one right up the top there. I actually have to extend this line up. Not the best extension I've ever drawn in my life, but hey, we'll blame it on the colouring pencils. Now, when you go to do these ones, you'll see why this technique is much easier than just stepping across all the time. You can kind of fly through these ones, just like that. And I always do a tiny little line just before I draw it, just because sometimes it's hard to see visually where the tip of the compass is going to contact. And now I can see it once I draw it. I also will draw the curve from here, otherwise you can lose track. Now it's easier to keep track in a parabola or a hyperbola, but in ellipses it can be a right nuisance. Okay, there's my curve. Now, what about the second half? Should we, shouldn't we? Let's have a look at our time here, 4:15. So let's just mark these all off one by one as an axial symmetry. And you can see it's actually not that hard to do. So if you're trying to figure out, is it worth it, should I, shouldn't I am going to have this done in about 30 seconds, I think. Yeah, bang on, 30 seconds, and they're all marked. So, you know, exams have a little bit of time pressure and all that, but usually you can find 30 seconds for something like that. There we go. And just freehand in the curve. Now my construction lines are all a bit heavy here, so you can see them on the video. Yours should just be a little bit lighter. There we go. All right, that's our parabola. Now what's our other little bit? Draw the tangent. Don't forget that sometimes people kind of go, yay, parabola done, run away. We also do have this little guy here to draw. 45 millimeters from the focus. Well, now this point is obviously going to be on the parabola. Okay, so we'll just measure 45 mil with our compass. And we'll see where that brings us. Now we're going to have one top or bottom. Do they say? It doesn't really tell us which one we need to do. I'm just going to draw mine on the bottom because there's just a little less going on down here, so it's a bit easier to work with. So 45 millimeters from the focus is going to be there. All right. So that's just over 45 out to there. So there's my point, P. Now, a couple of ways you can do this. Again, I just like to kind of stick with the one that's common to them all. So if we join P to the focus, okay, there we go. And pop our T-square out of the way. And we need a line 90 degrees to that. There we go. Okay, that's 90 degrees. From this point to P is going to be our tangent. And a little bit of common sense, you see, yeah, that does seem to work very nicely. And there we go. That's my tangent.